Alright everybody, welcome to the Chapter 6, Section 1, Notes on Graphing Systems of Equations. This is not an easy unit, so if you, this is the easy section of the unit, but this is not an easy unit. So if you know somebody who hasn't watched the video or hasn't watched it yet, please share the video, text them, do something, because we need to make sure we're watching these. This is a difficult unit. Systems of equations are just multiple equations, okay, in the same problem. That's the thing. So we're going to talk about possible number of solutions when we have a system. We're going to look specifically at an example first, obviously, and we'll kind of get the hang of it. This first one, we're going to look at this problem up here, this bands, CDs. And so we have two equations in this problem with the CDs sold. The CDs sold can be modeled by y equals 10x. And then we also have the formula for the cost of producing a CD, which is 4x plus 1500. And so we're going to take a look at these two equations at one time as a system of equations. So what we're going to look at is we're going to look at the possible solutions for a system. So the first, if a system has one solution, it is said to be consistent. This is vocab. A consistent solution if it has one, a consistent system if it has one solution. That means the graphs intersect at one point or they are the same exact line. If a consistent system has one solution, it is independent. So that should be easy to remember. Independent is like when you're on your own, so you're one. If it has infinitely many solutions, it is dependent. Okay? And then the third option is that if a system has no solution, it is said to be inconsistent, and that's when the lines are parallel. This picture right here, I think, does a really good job of explaining the three different solutions we could possibly have. So we could have exactly one. When we have exactly one, we have a consistent and independent. Okay, consistent and independent, and that's when we have one solution. That's where they intersect. Okay. We could also be consistent if there are infinitely many solutions. So consistent, but now dependent. The lines depend on each other because they are each other. And then we could have no solution, and that's when the two lines are parallel, and that's called an inconsistent system. So those are your three possible solutions for linear systems. So let's take a look. We're just looking at use the graph at the right to determine whether each system is consistent or inconsistent, and if it is independent or dependent. So first, we just know that consistent means it's got an answer. Inconsistent means they're parallel. And then dependent is they are the same exact line. Independent means that they are two different lines. So we look at y equals negative 2x plus 3. That's the blue. Right? And then y equals x minus 5. That's the purple. We can see that blue and purple, they are going to intersect. It's going to be down here somewhere, but they are going to intersect. So that's a consistent and independent system. Okay? If we take a look at y equals negative 2x minus 5, that's the red. And negative 2x plus 3, that's the green. These are parallel. They have the same exact slope, so there's no solution. So the system is inconsistent. Go ahead and pause the video real quick right here and see if you can get answers to 1A and 1B. Go ahead and pause the video now. All right, you've unpaused. Hopefully for both of these, both of them, you got that they were, excuse me, that they were consistent and independent. Okay, one answer, intersection and one answer. So solving by graphing, what we're able to do, and we can do this on our calculator, we can do this by hand, and we'll practice both, is you just graph them both, and wherever they intersect is the answer. It's really just that simple. Now we have to do some things sometimes where we're going to have to manipulate equations like in part B so that we can graph them. So we need to change those to y equals mx plus b. And then when we do that, we see that the two lines are parallel. They have the same exact slope, so that system is inconsistent and has no solution. So go ahead and take a second, grab some graph paper or sketch these. Go ahead and graph each, determine the number of solutions, and if it has a solution, go ahead and name it. Go ahead and pause the video here. Try 2A and 2B. Pause the video now. All right, you've unpaused. Hopefully for 2A, you got that there was one solution and that it was 3, 1. Okay? And for 2B, hopefully you got that there were infinitely many. That is some fantastic handwriting right there. And just like that, my handwriting's better. Okay, real world examples. The only reason these are more difficult now is that we're going to have to take the words and use the words to create the equation. But other than that, it's the same exact thing. We're still going to take the problem. We're going to set up an equation like we did here. We're going to graph that, and then we're going to look for the intersection. And the other nice thing about this is that we can, and it talks about this in this example, we can always use substitution to check our answer. Whatever x and y we get, and we could do this up here too, whatever x and y you get, if I put 3 in for x and 1 in for y, 3 minus 1 is 2. And then if I put 3 in for x and 1 in for y, 3 plus 6 is 9. So I can always substitute the answer and it's back in, and it should work for both. Okay, so that's not a bad idea. Go ahead and take a look at this video games problem with Joe and Josh. Joe has $14 and saves 10 a week. Josh has 26 and saves 7 a week. And how many weeks will they have the same amount of money? Okay, go ahead and come up with a solution to that. Go ahead and pause the video and come up with an answer to that. All right, you've unpaused. Hopefully you got 4 weeks. Okay, if you didn't get 4 weeks, let's take a look at some equations. Joe equals, let's see, y equals, he's going to save 14, he has $14 and saves 10 a week, so 10x plus 14, yikes. And then Josh has 26 and saves 7 a week. So here's the equations. If you didn't get 4 weeks, go ahead and try those again. See if you get 4 weeks now. Hopefully you do. Once you're done fixing that one, if you needed to, go ahead and take a second. Try these 9 problems. The first 6 are just working on vocab using this picture. 7 and 8 are practice with graphing, and 9 is a word problem. Try those. Come with questions. Make sure, talk to somebody. Text or tweet or whatever, one person and from class, and see if they watch the video so that we are all on the same page from the very beginning. All right? See you next time. Bye.